Hello everyone. In this video I'm going to demonstrate the method of decomposing an expression, a rational expression like this, ratio of two things, into partial fractions. Now it's important that the denominator here, we have two linear factors. We'll deal with a more complicated one in a minute, but x minus 2 is linear, x plus 2 is linear. Remember, it's linear if the highest power on the pronumeral x is 1, which it is. So we want to write this as some fraction which we don't know the value of a, over x minus 2, plus some different fraction b over x plus 2. And if you think about it, that's fine. We've been adding fractions ever since we were in primary school. If we had two fractions, we could add them. We'd find a common denominator by multiplying these two. That's exactly what we have. So let's work this process in reverse. If I were to add these two, I'd have to go a multiplied by the term x plus 2 plus b multiplied by the term x minus 2 from over here. And now we would have our common denominator of x minus 2, x plus 2. So the numerator here is 12, and the numerator here is a times x plus 2 plus b times x minus 2. The denominators are the same, the numerators must be equal. So we would look at the fact, we sort of go, therefore 12 must equal a times x plus 2 plus b times x minus 2. Now we have to find the values of a and b that make this true. Remember, x is a pronumeral. X can be any number we choose. We could choose x equals 5. But that wouldn't be a very easy choice because we'd still have two pronumeral, two a and b appearing in our expression. We have to make a sensible choice here. Now the sensible choice would be to choose a value for x where one of these terms disappears. An obvious one would be here. If x equals 2, then this expression would become 0, that bit would be gone, and we're left with 12 equals a. Now we said x was 2, so 2 plus 2, 12 equals 4 times a must be 3. That's good, we know a. Now we do it again, and this time we'll choose a value for x which makes this term disappear. X should be negative 2 in this case. If we let x equal negative 2, we rewrite the expression, 12, that bit's nothing. So we'd have b, negative 2 for x is what we, and then minus 2 from this, and we'd have 12 equals negative 4 times b. It seems like b equals negative 3. So our decomposition then, if we want to restate what we started with, we had 12 over x take 2, x plus 2. A turned out to be 3 over the factor x minus 2. B turned out to be negative 3 over the factor x plus 2. So we're finished. We have taken a rational expression which had two different linear factors in the denominator, decomposed it into what we call partial fractions. So this is part of the original, and this is the other part of the original. Both of these are simple fractions now. And that's just the first one. We'll do some more in the next video.